Oh no. Oh. Good afternoon, class. Today we're going to be talking about something called systems of equations. And in particular, we're going to be looking at systems of linear equations. If we're going to be thinking of lines, let's begin this. If you were told to draw two lines, if you had to draw two lines on your sheet of paper, there's really only three ways you could do that. You could draw two lines, a purple line and a red line, where they intersect in just one point. Is it possible to draw two lines that never intersect? And if so, what are those lines called? Parallel. So you could draw two parallel lines, and parallel lines never intersect. Never intersect. And then there's one other possibility that people don't think about. If you drew one line on top of the other line, if you had a blue line, a purple line, and then when you drew your second line, if it was right on top of it, if that happened, if you had one line on top of the other line, then it intersects at every point. What we're going to be looking at in this assignment is how to find those points of intersection. If you have two lines intersecting, how do you find the point of intersection? Theoretically, you might have a thing where there's no solution. Now, I think a lot of the word problem, not the word problem, is the assignment. It'll mention, have that second option, there's no solution. That would be if the two lines never intersected. Okay? But most of the time, the interesting times, that's where there's just one point of intersection. Is it possible to draw two lines and have them intersect in 2 points? Only two. Could y'all draw two lines and they intersect in 2 points? Say no. No. No, you can't draw two lines. They're either going to intersect in 1 point, they're going to never intersect if they're parallel, or they're going to intersect in every point. And that would be that every point is one line on top of the other. Well, we're going to have several methods of solving these systems of equations. And the first method we're going to use is something called substitution. And I will demonstrate substitution with the first example here. Problem number 1 says, solve the following system of equations by the substitution method. And then if you look over here at all this type, if the solution is, when you type the solution, you type an ordered pair, because when two lines intersect, it's at a point, x, y. Notice how they give you these other two options. Infinitely many solutions or no solution. The no solution would mean that you have parallel lines. The infinitely many solutions, one line on top of the other. And I'll show you how to determine those. But I'm not sure that at least that never happens when I'm solving them. For me, when I do them, there's always just one solution. These other two are actually the easier case. Okay, so let's write down these two equations. This is problem number 1.
4x plus 9y.
4x plus 9y
equals 26.
equals 26.
Next one, x equals 35 minus 7y.
Okay, x equals 35 minus 7y. So we're trying to see, do these two lines, how do we know they're lines and not circles or parabolas? Well, notice there's no exponents. These are both linear equations. That's how we know it. It's a black line and a red line. One thing we could do is draw those two lines and try to see the intersection just by looking at that. But what we're going to do is something called substitution. And the name substitution sort of tells you what you're going to do. We're starting off with two equations and two variables. We're going to rewrite it with just one equation and one variable. The way we'll rewrite it so that there's just one equation and one variable is to substitute. Look at this equation right here. X equals. Let's plug this 35 minus 7y in for x. It says x equals. So let's replace that black x with 35 minus 7y. And you think, oh, well, that looks worse than did to begin with. No, it doesn't. Because at this point, you know how to solve this equation. You just have one equation with one variable. Up here, the way you have those two different variables, how the heck are you going to solve and get an answer there? So we've gone from two equations with two variables down to this new equation. It's just one equation with one variable. Well, there's two y's. How would y'all go about solving this linear equation? Distribute the 4. That's the only correct first step. 4 times 35, that would be 140. Minus 28y. Plus 9y equals 26. Now, what can I do? Okay, so I distributed the 4. Combine the negative 28y plus 9y. So we have 140. I'm carrying that down. And then negative 28 plus 9. Oh, I'm thinking negative 19. Okay. Negative 19y equals 26. Okay, so you're now trying to isolate the y by subtracting 140 from both sides. Oh, I guess I could just move the arrow, but I drew an arrow, but I didn't.
Negative 114.
Okay, so we have negative 19y equals 26 minus 140, and negative, what did you say, 114?
Yeah.
Only one thing left to do here. Divide both sides by negative 19. Negative divided by negative is positive. What are we getting for y? 6. Negative 114 divided by negative 19, 6. Okay, if you got me, punch it into your calculator. And we're not finished yet. All we've done is found half of the answer. Okay, so did y'all hear that? Well, our answer should be an ordered pair. When two lines intersect, they intersect at a point, an x, y. Okay? Okay, well, you have the y equals 6. So I'm going to go ahead and write 6 right here. It doesn't matter which one of them you plug into. You can plug the 6 into the first equation or the second one, whichever one you think is easier.
Into any of those equations?
And the original equations, I think what I'm going to do is plug it into the red one because the x is already isolated here. So I'm going to choose to plug the 6
Into the y.
Okay, so we have x equals 35 minus 7 times 6. So that's 7 times 6 I'm going to replace with 42. 35 minus 42 is
Negative 7.
-7. So, and this is called substitution. You're substituting one variable expression into the other equation. Now, there is a nice way you can check these without just plugging it into my, what am I doing? You can't even see my writing there. Sorry about that. There's a nice way to check these. You can just plug, these solutions should make both statements true. Like if I plug the -7 in for the black x and the 6 for the black y. 4 times -7 would be a -28 plus 9 times 6 is 54. Does that equal 26? Yes. -28 plus 54 is 26. By the way, what I'm doing right here is just an optional, which means you don't have to do it. You have the answer once you circle that -76. Checking. If you were taking a test and you wanted to check and make sure it was right, okay? It's pretty easy to do. Just take the two numbers, plug it into both of the equations. It should make both of them true. Did it give us a 26 on the first one? Yes. That one checks. Now, checking it down here, x, -7, equals 35 minus 7 times 6 is 42. Are we getting the same number on both sides? Yes. So that one checks. So I'm 100% confident that -7, 6 is the correct answer. Parentheses, -7, 6, close parentheses, and check the answer. This is called substitution, and you have to notice that it was convenient that one of the equations says x equals. Suppose we had something like this one on number 2. On problem 2, there's not one of the variables already isolated. So you need to figure out which one would be the easiest to isolate. Like if you were going to try to isolate this first x, you would move the y over and then divide by 4. That's going to get you fractions. I would not use substitution if it meant winding up with fractions to work with. Like right here, if I were trying to get this second x by itself, what did I ultimately have to divide by 7? Could y'all imagine doing that? How would you get this x by itself? You move the 3y over and then do what? Divide by 7. Oh, I don't want... I'm trying to make the equations look like these, where one of them is in the form variable equals. No fractions.
You had plus 3y, and then you divide by 7.
Okay, you could, yeah, but you're going to wind up having to divide by 7 and get you a fraction. Which one of these variables is the easiest one to get by itself?
Y.
This one right here. So let me write that down. And there's an addition. This one has that additional step. Number 2. We have 4x plus y equals 11. And 7x minus 3y equals 5.
Doesn't matter whether it's X or Y. Just get it like by itself.
Okay. Did y'all hear that? We can isolate this y by just moving the 4x over, by subtracting 4x. So if I move the 4x over here. Oh, shoot. Sorry.
Okay, it's okay.
Yeah. Okay. So I'm trying to get one of these variables by itself. And the easiest one to get by itself is this black y, because then I'm not going to wind up with any fractions. I have a y equals 11 minus 4x. Did y'all hear that? You put that into that other equation. So right here where we have the red y, I'm going to put this green 11 minus 4y. I'm going to use a little arrow and go like this. Are y'all following what I'm doing? I'm going to get an equation that has only x's, no y's. Okay. Distribute and distribute. So if I distribute this 3, I have a 7x negative, okay, yes, so it'd be a negative 33 and then a plus 12. Did y'all hear that? X. Okay, so combine the 7x and the 12x. That'll give us 19x. Minus 33 equals 5. Mary May, you're ahead of me, aren't you? Because you already have the...
Then you plus the 33 over.
Uh-huh. So we have 19x equals 38. Divide by 19 to get x equals 2. Now plug that in, and here's the thing, it doesn't matter which one of these, even this one here, okay? You can use the black equation, you can use the red one, or if you want to use this one here where you already have it solved for y, that's fine. I think that might be the easiest one to use. What do you think? We're going to plug a 2 in.
So you can use the y equals...
Uh-huh.
So then you have to use that one.
Y equals 11 minus 4 times 2. So 11 minus 8. So y will be 3. So you write your answer as an ordered pair.
2.
Okay, 2, 3. In another class, a business class, a student emailed me and asked, said that she thinks she got the answer wrong because of the commas. Did we have to plug the commas in on the answers, or do you have to put a comma on the answers? And I thought it was a business math class where they're writing things like, okay, find the amount of money the profit this business is making off of this, and they're punching in something like $1,492,357.92. And so I thought that's what she was asking about. And I told her, no, you don't have to put the commas in numbers. You don't have to type in 1,000,000 on Pearson. You don't type 1,000,000, comma. Just type a 1 and 6 zeros. And I thought at the time, once I sent the email response to her, I thought, this is a very strange question for someone to be asking so late in the game. In that semester, all semester long, they're punching in these big numbers. I thought, let me try to figure out what she's looking at. And so I started looking through her work, and I found a problem where she had to type a subscript, x1, comma, x subscript 2. She had put the comma down there in the subscript, and that was the only thing wrong with it, but Pearson marked it completely wrong. It goes back to stuff that we had mentioned earlier to y'all about where that comma goes when separating stuff. That's what made me think about that. She had put the comma in the subscript, so it counted it completely wrong. Just like if you didn't put the comma in your answer, what do y'all think it's going to do? It's not going to even know why. You know, if I do this, I suppose I'm at parentheses 2, 3, close parentheses, of course it's going to count it wrong. Or just sign and sign and sign. Okay, you see, well, but I'll put the comma.
So you kind of
You like the comma.
There.
Wrong answer.
Now, let me go ahead and tell y'all about these infinitely many solutions and no solutions. If when you're going through all of this, and again, it's never happened with me with these problems. Okay, there's always been solutions, but I don't know if we can judge the present or the future from the immediate repeated past. But when you're going through these calculations, if everything started subtracting out, if everything subtracted out and you wound up with 0 equals 0, I know it sounds bizarre, but if when you started distributing and adding everything, if you got rid of all the variables and just wound up with a 0 on one side and a 0 on the other side, then that's one for there's no solution. It never, no, that's not right. That's this one, 0 equals 0. For the never intersect, if you wind up with 0 equals a non-zero number. Real quickly, I'm going to demonstrate what I mean by that. Okay? I'm going to make up one for it's either the never intersect or the always intersect. Okay? And let's see if y'all can figure out which one it is. So let's say example. Solve by substitution. Suppose we had 4x minus 8y equals 13. And my second equation is x equals 10 plus 2y. Suppose we had those two equations. It looks like a pretty straightforward substitution. Well, how would y'all substitute? Okay, put the 10 plus 2y, since it says x equals, put it right there in place of that black x. And look at what we have. We would have 40 plus 8y. Did y'all hear Mary May? What's about to happen to the variables? Okay. So the 8y subtract out. Theoretically, y'all could just stop right there. But if you continue on, okay, let's try to get a 0. If we move this 40 over here, we have a 0 on the left, and what do we have on the right? If it's another 0, then it intersects at every point. If it's some non-zero number, then it never intersects, and there's no solution. Negative 27. So we have 0 equals non-zero, no solution. The two lines that I wrote here are parallel. Oops. And again, I've never seen that happen on these problems that y'all are doing, but
Be safe
yeah,
and sorry.
if it happened, huh?
Be safe
Yeah.
and sorry.
And that's called substitution. And it has some drawbacks. The only reason or way you would ever want to use substitution is if there's one of those variables that you can easily solve for without getting a fraction. If there was some number in front of this y here, I wouldn't use substitution, even if it said use substitution, because you're going to wind up with a huge mess. You're going to be plugging fractions in down here. Well, here's another method that we could use, something called elimination. With the elimination method, you need to have the variables, the like terms, lined up. So we have the equation x plus 5y. Oh, okay, I'm just writing down the problem right now. Oh, wait, no, I can't switch because I haven't written it down.
I thought you were writing words.
X plus 5y equals 36, and negative x
Plus 2y
plus 2y equals
equals 15.
15. Same rule applies. If you wind up with 0 equals 0, then there's infinitely many solutions. If you get 0 equals non-zero, then no solution. Let's see. With elimination, you're going to... This. It's not 15, it's 13. Oh, okay, thanks. Oh, wow, this is one of those times. Our house has this big plaque with our house number on it, and it's gotten so hard to read. And so we bought these numbers, and Tim was like, let's just stick these numbers over the numbers that are there. And I was like, oh, Tim, I think it looks like you're going to wind up making it look like what I do whenever let me go back over that number. And let's see, I guess I haven't done it. But right here, I nearly started to change this 15 to 13. And it was going to be such a mess, that's why I marked it out completely. Okay, because every time I try to correct a number by writing over it, it always makes it look worse. With elimination, you just add vertically. Your goal is to get rid of one of the variables.
It's the X.
Yeah, we're going to eliminate the x by just adding vertically. X minus x, 0. 5y plus 2y, that's a 7y. It looks like I just put some decimal points there. I did not.
49.
And then 49, 13 plus 39 is 40. 13 plus 36 is 49. And then divide both sides by 7. And we get y equals 7. I like the elimination method. Okay? But even the elimination method has some drawbacks that we're going to discuss in a moment. Here, it's completely up to you which one of these do you plug into. You have your answer for y, Answer for y is 7. Let's find x. Well, I think I would use the first one. Why am I choosing that instead of the next one? Well, I'm using the one without the negative. Okay? If you want to use the one with the negative, okay, that's probably going to give you one extra step. If I plug the 7 into that top equation, we'd have x plus 5 times 7 equals 36.
5 y equals 29.
X plus, wait, 5 times y is 35. And then what do I do to get the x by itself? Subtract the 35, so we're going to get x equals 36 minus 35. Is that a 1? So I'm getting 1? Remember, if in doubt, you can check it. 1 plus 35 is 36. I'm plugging the 1 and 7 in. Let's do it in the purple one down here with this negative. We'd have negative 1 plus 2 times y, 2 times 7, that's 14. Is that giving me a 13? Negative 1 plus 14, does that equal 13? Yes. So here is my answer. Come over here and write that one in. If everything, all our work had just reduced down to 0 on one side and 0 on the other, we would have said infinitely many. If we had wound up with a 0 on one side and some number other than 0 on the other, then you would have said no solution. 1, 7, close parentheses, and check the answer. Okay? So with elimination, it's got to be, you got to have the like terms lined up. You can't have x's and y's lined up.
Can you rearrange the problem to where it does?
Yes, if it didn't, but right here, I think the x's are lined up.
Yeah,
Y's
like,
yes.
Like on the first problem,
Yes.
where it was a substitution method, you rearranged, you could use the elimination method anyway.
And that's exactly what I would do if,
Okay.
I always prefer elimination over substitution. It's very rarely that I choose to do substitution. Okay? Let's see. 4x plus 6y equals 12. And 8x minus 6y equals negative 120. If I add vertically, will we eliminate one of the variables? Yeah, those 6 y's will be gone. So we have, let's see.
Or negative 4. I'm sorry.
Wait,
12x.
I'm thinking 12x, unless I miscopied it. Oh, wait, I haven't even, let me, okay. The 6's are subtracted because we have 6 minus 6. But here these are both positive, so it's just going to be a 12x. 6's are gone. Equals, what is that? A negative 108? 12 minus 120? Is that a negative 108? Divide both sides by 12. And, does 12 divide evenly into 108? 9? Negative 9? Okay. So we have x equals negative 9. Plug it into whichever one you want. Huh. Is that what y'all would use? The 4x plus 6y equals 12 because there's no negatives on it? So we have smaller numbers, So I'm now going to solve for y. So we have 4 times negative 9, negative 36, plus 6y equals 12.
Plus 36 to get y.
Add 36 to both sides. And we have 6y equals, is that a 48? Divide both sides by 6. And we get y equals 8. So the y value is 8.
So negative 9, 8. All in
Oh. Oh, wait. We've already found the, I was getting ready to plug that in to find the, okay. Oh, that was stupid. Negative 9, 8.
He's like, I'm ready to go.
Oh, wow. No, I was just thinking, wow, last fall we had 2 of these classes, a Monday, Wednesday, and a Tuesday, Thursday, and it was right after this class period, but my brother and I both got COVID and were absent pretty much the rest of that fall semester. We were both, my brother, with his weakened immune system, he never got real sick, but he tested positive every day for about a month. He never could, and the school policy was once the symptoms were gone, we could return to work, and fortunately, we were finished. Students wondering, why, there's still 2 weeks left, what are we going to do? Well, that was not my desire to say, let's all of us have, or let me and Tim both get COVID. But we were sick from before Thanksgiving. I think we got sick like the Monday of the week before Thanksgiving, and then we were able to return at the week of.
That's 14 days.
Yeah.
I know. I used to work in Colorado. I was in the midst of
Mm-hmm.
all of the viruses in 2019 through 2022.
Oh,
Yeah.
wow.
I never got it.
Wow, you're
But I
so
was in the midst
rare.
From when it started. Man, the grocery stores were bad.
That's why. Look at your blood type.
I'm just saying, I have no idea.
You see, I don't
I have
know
no
either.
idea. I just know
Mm-hmm.
I never got it.
They're doing
Even my fiance got it and I didn't get it.
They're doing studies on blood types.
I wonder, like our mother, she's 95, about to turn 96, and we went several days not realizing we were sick. At first, I was just convinced it was a cold because I always had a mask on. After that, I decided, I'll wear a small mask. I got it anyway.
Yeah.
What's those
Yeah, I wear
N95 masks? What's the purpose if I'm going to wind up getting it anyway? So I'm just wearing a small mask to prevent colds. But my mother, 95 years old, she never got it. And she lives with us.
Oh.
I'd be interested to see your blood
Yeah.
type.
You know.
I'll let you know.
Oh.
I have a lesser chance of contracting COVID.
Mm.
They've had studies on it.
Oh. You got it twice? Never badly. It's just
The first time was bad.
Oh, okay.
I slept for like 3 days straight.
Oh, wow. Well, I'm glad that.
Just come back from the camp. So I don't know if it was just because I got COVID or because I was tired from camp.
Oh, okay.
But everyone got it in camp.
Oh, wow. Okay.
Well, how sick did you
Hmm. Well, let's look at this one. I said we would discuss the problems with what's it called, elimination, and I think here's the one.
You can't really cancel anything.
Yeah, if you just add vertically, are we going to eliminate one of the variables? No? Well, what tools do we have? Don't say use substitution. Theoretically, we could isolate this y here, move it over there, and use substitution. But what I prefer to do is to stick with elimination. We need the same number, but with opposite signs on the x's or on the y's. What could we multiply either one or both of these equations by in order to get both of these numbers the same number but with opposite signs? That's what we need. Same numbers but with opposite signs. Okay, so like we can make one of these 18 and one of them negative 18. Or what about over here? What could I multiply this y by?
1.
Oh, if I multiplied this whole second equation by positive 2, that's what I'm showing here with this little 2. I'm going to try to multiply straight through here by 2. Why would I do that? What would happen? I'd have 4x minus 2y equals negative 2. Why is that? Now do y'all see, are we going to cancel out these y's here, the 2y minus 2y? I'm making this problem look like the previous one, where we had the 6 minus 6.
You don't need to multiply both.
On this one, no. Okay? But it would be it's possible, like if you had chosen, I want to eliminate the x's instead, then make this positive 18 and this one negative 18. But that wouldn't be the smart way to do it. If the smart way is the easiest way to do it, it would be to multiply this second equation by positive 2. What you want is the same number, but with opposite signs, either on the x's or on the y's. So, now, are y'all caught up with me? Any questions on what I just did? That classic problem-solving technique. If you know how to do one problem and you're confronted with a new type, make it look like the old one. That's what I did. I made problem number 5 look very much like number 4 here.
So would it be 14x equals negative 13, or am I totally off?
Oh wait, I'm thinking it's 13x equals negative 13. Am I right? The 9x plus 4x? You're making it a much harder problem. If you put a 14 here and wind up with x being a fraction, divide both sides by 13, and we're getting x equals negative 1. Well, just plug into one of the original equations, whichever one you want to use.
2 in parentheses negative 1.
Okay. So you're using this one right here? Second one? Okay. 2 times negative 1 minus y equals negative 1. Are y'all caught up with me?
I guess I should have used.
Oh, so you're thinking
They both had
you're now,
negatives.
but the fact that this minus here, is that why you're thinking, oh wow, I should have used the other one? Okay. We'll still do it this way. We'd have a negative 2 minus y equals negative 1. I'm going to use my little arrows to show y'all what I'm about to do. Let's see, I was going to do this.
Plus 1.
Move the y over there to make it a positive y, and move the 1 over here. But if you want to add 2,
That's just another way.
then you just divide by negative 1. You're still going to get the same answer. If I move the y over to the right,
Equals negative 1.
Negative 1?
It's just some extra stuff you don't need to do. That's
No.
why I was like, oh, I picked the wrong one.
Or,
So one more.
now, I'm going to say or because if you had done it like this, if you'd said, okay, let's move the negative 2 over by adding 2, you'd have negative y equals 1. Divide by negative 1 to get the same answer. Y equals negative 1. So it really doesn't matter which one you do. It might have been easier to plug in the negative 1 right here.
It still
What?
works.
Yeah, is it just negative 1 comma negative 1?
No, that's the same.
So negative 1 comma negative 1. Parentheses, negative 1 comma negative 1. Close parentheses. Oh, wait, can I see that? And now, before I do anything else, I'm going to give y'all a little terminology. In algebra, a matrix is a rectangular arrangement of numbers. Just a rectangular arrangement of numbers. So if you have numbers arranged in a rectangle, we call that a matrix. The rows of a matrix, that's the horizontal. And, columns are vertical. I want to write a matrix for y'all.
A rose horizontal is called what?
The rows are what we call the horizontal ones rows, the vertical ones columns. Like on this matrix here, negative 3, 4, negative 5, 7, 0, 9. If I talk about rows, because I said read out the first row, that would be negative 2, 4, negative 5. If I said, what numbers are in the second column, what do y'all think you would say?
709.
Column. Vertical. The second row would be 709. Okay?
Rows are the horizon.
Now, the size of a matrix, if someone says, give the size of a matrix, you're looking at the number of rows by columns. And the by we usually write with the X, but we're not multiplying. We would say that this matrix I have right here has how many rows? 2. And how many columns? 3. It's a 2 by 3 column. And we could spend a semester discussing matrix algebra. Instead, we're going to do a few problems and move on. Problem number 6.
These are rows? That's it?
Rows are horizontal. Okay, so the rows are row,
Well, then why are you saying that
Column.
rows are 2?
column. There are 2 rows. There's only 2 rows. I'm not saying how many numbers on each row. Just how many. There's 2 horizontal rows, 3 vertical columns. This is what's called a 2x3 matrix, which is different from a 3x2 matrix. Oh.
You get it?
I'm just writing it down so I don't forget.
Oh. Writing what down?
Where it says -2 and 7, right on the left, I'm writing row, row, and then on the bottom side, I'm writing column, 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 so that I know.
Row, row, column,
Yeah.
column,
Oh, that's what
column. In fact, I'll be more specific. Row 1, row 2.
There you go, yeah.
Column 1, column 2, column 3.
Okay, that makes a little sense.
Now, problem number 6 will probably represent one of the hardest problems we've done this semester. I'm sorry, but it had to
I
happen.
wrote this.
Okay, problem number 6. It says, write the augmented matrix for the following system of equations. I'm going to go ahead and write this down. -7x plus 7y equals 2. 6x minus 2y equals 2. It says write the augmented matrix. For writing the augmented matrix. This is something new that's very difficult. I'm writing it out. Augmented matrix. With the augmented matrix, could y'all imagine, look at this system of equations. Could y'all sort of imagine it without the x and the y? You would sort of see a matrix forming. Well, we're going to have an x column and a y column. The equal sign I'm going to write as a vertical bar, and then over here the constant. You're just going to write, I'm joking about it being hard. I'm making it sound hard. I'm doing a very poor job at this. Just write down the coefficients. -7, 7y equals 2. Does someone want to tell me the numbers? The red numbers I'm going to write on the second row. 6, 2, yeah. Yeah, I'm joking about it being the hardest problem this semester. Huh? And you type in the interest here. Okay, there. This one's one you could really do without writing anything.
That's literally all.
-7, 7, 2, 6. Oh, well.
What if it was not done so quick?
I was happy with those.
Right?
Those I didn't say them words. As long as you get columns and rows, that is. Now the other ones are hard.
They used to, this question used to have a second part. It would ask, what's the size of the matrix? And I guess they don't do that anymore.
Hey.
Yeah. Now, here's another one.
But you don't have to put anything on any side. You literally just plug it in.
You've got to make sure that those variables are lined up.
How many
If
rows
the
are there?
X, Y, and Z
So
weren't
where's the
lined up, you would have to move the stuff around.
So then,
You want to call it out?
5x.
Okay.
well, just 5.
Just a 5. Don't put the X.
-1.
And then
Uh-huh.
a -1.
0,
-1.
negative
Oh, I'm going across. It's -1.
And then a
Wait.
5.
The 5. Okay, I'll hit tab. 5
-6.
equals -6. Okay. Oh, gosh. You know what? Maybe I'm going to make this a little bit smaller so maybe it'll fit better. Okay, there.
Hey.
Okay, so 3
-5.
tab -5.
1
Okay, a 1
and 8.
and 8. Now here's the tricky one.
There's nothing there.
I've got to put a number, so I'll put a 0.
Oh.
Okay?
I thought it was
Do y'all
gonna
see
be
the
a
difference
number.
between when I
I thought
put
it
a
was gonna be
0 and a 1? A 1 means the variable's written there, like right
Right.
here, a -1, but right here, just a positive 1. So 0 there, then a 4, a -8, and one more -8.
Whoa, wait.
Okay,
Almost
there.
done. I was answering and I didn't write it down. Just to have it to remember.
Okay.
Okay.
Okay. Are we ready to do the next one? Next one's where it's going to get much harder.
Of course. You say that, but
When
I don't
in
believe it.
algebra, you always do it one way, and then what do you do?
So I see.
Do y'all see what this one is? Is it really much harder?
-9z.
CZ.
Okay, good. What am I going to put right here?
3.
3. Now
Negative
this is
9.
oh, it's already got the negative. It's not they deliberately made it tricky. Just put the 9, 8.
Write this.
6.
Okay, notice there's no x, so 6,
And then
and then -2,
-2. And a
Yep.
5.
5,
And an 8.
and 8. Boy, I don't like the way these aren't lining it up.
I know.
It's
I
a little
like
weird,
those
but-
variables to be lined up. It seems like Pearson should get a programmer that can write
Get
the
their
thing
thing
so
together.
it'll be
They need a
lined up.
OC programmer.
Now,
I kind of miss the old days where you like brought in your paperwork and they got to see looking good and all of your work.
oh,
I do.
mhm.
I do. You got credit on partial. You don't get partial on test.
Mhm.
True. I have a teacher that gives a lot of positivity.
Oh.
No, 10, 12 years ago was a lot different. Yeah.
0
Uh-huh.
and 0. 0, 0, and 1.
Hmm.
it's not.
Wait, what are we
Okay.
doing? Okay.
I already did.
We're doing, it's the same as this. But look, there's a lot of zeros here. So what would this first row be?
100?
No, write the equation. Use the letters X, Y, Z.
Yeah,
Let me write it down.
1X?
Okay, so number 9.
I'm gonna have to write this one down, y'all.
0, 0, 0, 1, 9, 8, 6. So we're going.
Getting it.
Oh, it's just so easy you're not getting it. Okay, you're making
I
it
know.
harder. Okay, you're given this matrix and it tells you use X, Y, and Z for the variables. So write the equations. This first row, it would just be X. There's no Y or Z. So you just have X equals 9. The second row would give us what? There's no X or Z, so Y equals 8. And,
Where's the 1?
oh, do you want to put the 1 in front of the Y? Is that what you want to do?
There's
Okay,
one
I get you.
There's one way,
I
there's
get what
one
you're
Z.
doing. Okay.
And so here, no X, no Y, 1 Z, so just Z equals 6. And when you look at how they have it written there for you, they have the 9, 8, and 6. You type in the
Oh my God.
X,
You're kidding me?
Y, and Z.
Is that why you were laughing at me?
I wasn't laughing. I'm just.
It's like
This is the greatest finale of the day.
Oh, well, it's,
It's
if you
using
have a
your brain in
matrix
different
like-
ways, like,
if you have a matrix like this, the preferred way to have it written is like this, with the ones down the diagonal and zeros
as funny as it
everywhere
gets, we share
else.
the same questions.
And there's a way that you can take a matrix like this, and there's a key on your calculator where you enter this matrix, and it goes through and multiplies and changes it up until it's in this form. Why would this be the preferred form? Well, when it's written with the ones down the diagonals, you actually have solutions. You don't just have an equation anymore. You have the solution for X, the solution for Y, the solution for Z. Okay?
So if there was a, like, so I know it says 100, and that says 010, and then it
That
says
has nothing to do
001.
with it.
What?
At all. It has nothing to do with
I know, but
With
I'm
100?
saying I have a different question. So
Oh, okay.
if you had 120,
Well, then
would
it'd
you
be X
put,
plus 2Y equals 9.
and you wouldn't have to simplify it.
Well, it wouldn't be...
That was my biggest thing.
Oh,
You don't
okay.
have to simplify the answer.
Okay.
If there's like,
Yeah, you're not
say
actually
there's one
solving
random
or
number.
anything. But in that way you are, because you do have the answers there.
Right.
I think we better get away from this and move on to something new. So leaving those determinants, those things alone, we're going to we're starting now something called determinants. Let me write down determinants. The word determinant in algebra is usually abbreviated just DET. In English language algebra books, if you see DET, it's standing for determinant.
Poison.
And the determinant is a way of assigning, poison, yeah.
Like, did somebody just say poison?
DET or DDT? You're thinking DD. Oh, DEET. Yeah, well, that's not this. Okay? And I think DDT is DDT, isn't that poison used during the Vietnam War? I think it was, way before y'all's time. Okay. The determinant of a 2x2 matrix. That's a matrix that has 2 rows and 2 columns. Is given by, it's been a while since we've had a formula. A 2x2 matrix would have 4 numbers altogether. I'm calling those 4 numbers A, B, C, D. And to find this determinant, you're going to cross multiply.
Interesting.
A times D minus B times C. Determinants are a way of assigning numeric values to square matrices. It only works for matrices in which the number of rows is equal to the number of columns. Important thing for you to do here is to look at the pattern. I don't mean memorize AD minus BC, okay? You're making a little X there. Make sure you're starting with the first number. If you do BC minus AD, you're going to get it wrong every time. Okay? Let me write down problem 10 and then we'll demonstrate this one. Find the determinant, -6, -8, 2, 1. Our answer here is just it's going to be a number. We're going to multiply these diagonals. Make sure that you start off using the first number. Somehow you got to remember to do this diagonal first, not this one.
You can't.
Oh, wait.
So,
Boy, I'm really... Okay. You've got to make sure we're doing this red diagonal first. That's why I say always start with the first number. So you're doing this one, negative 6 times 1. That's a negative 6. And then the minus from the formula.
And then a negative 16, so it actually turns
Uh-huh. Did y'all hear that? A negative 16. Notice how there's those two negatives. This blue minus is from the formula. And then negative 16, negative 8 times 2. So we have negative 6. Oh, I'm thinking it's smaller than that. Negative 6 plus 16. Oh, I'm still not agreeing with 22.
Be a 10.
Negative 6 plus 16. Would that be a 10?
hospital, sir, please
Okay.
don't slam that fuck on.
You get it, Jennifer? 10. This is a way of assigning a numeric value to these square matrices. So 10.
That one was easy.
Okay.
Let's,
Oh no, I think no, it still says we're connected. Oh, okay. Okay.
Okay.
This one will not be as simple. Okay? I'm going to show y'all how to find the determinant of how many rows and how many columns does this matrix have? 3 horizontal rows, 3 vertical columns. Let's see, 11. Let me write it down. 5, negative 5, 3. 1, 5, 4. And 3, 1, negative 7. Okay.
you need to find your...
It's
So would you
there's more to it than what we were doing with the 2x2. When you have a 2x2, it's just make the little X. For a 3x3, you've got to recopy the first 2 columns. So right here, I'm recopying 5, negative 5, 3, 1, 5, 4. And then you're going to do the crisscross. That's what we're doing here. We're finding determinants using the crisscross method. There's another method called cofactor method, which I won't be using. I'll do crisscross. If you look at view and example, they might show you cofactor. Okay?
You're going to tie the shoelaces.
Hmm?
You're going to tie the shoelaces.
You go like this. You're going to multiply, multiply, multiply. We're going to do 3 of those diagonals. 5 times 5 times negative 7. Oh, gosh. 25. Is that going to be a negative 175? Okay. So you multiply those first 3 numbers. Then do the second diagonal. Now that one I can do easily. 1 times 3. That's a positive 3. And then this third one. 3 times negative 15. 3 times negative 5 times 4. Negative 20 times 3. Is that a negative 60? Then
negative 60.
I put a minus. And now I'm going to do the other three diagonals, the ones I'm drawing the line through right now. Ooh-wee. 3 times 5 times 3. Is that first diagonal there a 45? 5 times 1 times 4. Is that going to be a 20? It's a positive 20, right? Then negative 7 times negative 5 times 1, 35. And then simplify each set of parentheses. Okay.
Does the negative 5 and the 5 cancel each other out?
The negative 5 and the 5.
That we didn't touch? Up top? No.
Oh, here? Oh, well, it just,
It just cancels?
well, you don't use it, but it was used. This negative 5 is that one right there. So it was used. Okay. Like this 5 here
Right, they're just like not.
was
they
this
don't
one
get
there.
used.
Right.
Mhm.
Okay. They're used, but, okay.
They're
Yeah,
not.
got it.
So negative 175 plus 3 minus 60. What are we getting for this red set of parentheses? Negative 232. Then the minus 45 plus 20 plus 35. 100. So negative 232 minus 100 is a negative 332. Any future physicists out there, you'll be doing a lot with determinants. Okay? That's why I'm using the crisscross method, because physics generally uses that method, not the cofactor method. So, I'm just spinning. I'll let that do that, and we'll look at this. So, the pattern for finding these determinants, you recopy the first two columns, and then multiply. That's those first three numbers. Then there's a minus the other three diagonals. Okay, multiply. Make sure that you are always doing this diagonal first. You should be using the first number when you're starting. Okay? A lot of times students will do this diagonal first, and they're going to get it wrong. Okay? So what can I say? Use the first number first. If you're not using that first number, then you're doing it wrong. Okay? Let me see if, okay, good. Okay, number 12. Good, I was hoping there'd be two of these. Number 12, just to make sure y'all got the pattern for these. Some calculators, you can punch this in. And if we were going to do a lot with these determinants, I'd pull up my calculator and show you how to punch it in on the calculator I have up here. But we're not doing enough to warrant that. Okay. Remember that pattern, how to find the determinant. You recopy the first two columns. So 4, negative 2, 7, 9, 1, 7. Make sure you're starting with that first number. Multiply. Oh, wait. Sorry. Boy, I'm bad at that today. Okay. Make sure you're starting. Okay, so the first red number is 0. What about the second red number? Oh, I like the ones where there's a lot of zeros. And 28, negative 2 times negative 2 times 7. Positive 28. There's always a minus in between the parentheses. Now we'll do the other three. So this first one here, is that a negative 14? Negative 2 times 1 times 7.
That is cool.
Oh, is it?
I don't know.
4 times 0 times 7. That diagonal is going to be 0. And what about this one? 0 again. I'll go ahead and put the zeros just so you don't think I forgot about it. So we have a 28. Now be careful. That minus and negative is going to be a positive 14. Minus and negative.
42.
42?
I think.
Mm-hmm. 42. 42.
You missed one.
I did.
Oh.
That's an easy. It's a cross again, right?
Yeah, it's one just like number 11, but it's having the zeros here actually makes it a lot. Let's see.
Yeah, it cancels it out. Yeah.
Oh, not all.
Not all zeros.
0,
The columns.
0. Here, this one was 28. There was no 0 on the third diagonal.
That's what I
And
thought.
over here, no 0. So it's a negative 14, and then 0 and 0. It's 11 and 12 are basically the same type of problem. Not basically, they are the exact same type of problem. I just wanted to make sure, just different
There's a
numbers.
tricky number in there.
And this one was nice because it had more zeros. If you get if you have these with a lot of zeros, then it's your lucky day. Buy a lottery ticket or something. You might win something. Now,
I'm buying a lottery ticket today.
why are we talking about these determinants in relation to the system of equations? Well, we have another method for solving system of equations, not just not just substitution and elimination. Here's a third method that we're going to see, and once we're through with that, then we'll call it quits and finish this up a week from today. Let's make sure we remember that on Wednesday, that's the in-class testing if you have a Chromebook to take your test on. So once we get to the word problems, we'll stop and finish those up in a week's time. So let's see. Problem number 13 deals with something called Kramer's rule. And it's just another way of solving a system of equations other than elimination and substitution. We've already done substitution and elimination. That was the first stuff here.
So it's not
Okay.
anything like that.
It's another way of doing it. Okay? It's another method for solving. Instead of substitution or elimination, and if someone asked you, poor Kramer, he gets a bum rap. He was a famous mathematician in his day. He's probably rolling over in his grave that the only thing he's remembered for is x equals dx over d and y equals dy over d. There's Kramer's rule, and you think, well, what the heck does that mean? That's what I've got to illustrate on the next example. Okay? This is a method for solving systems of equations.
But you can use the other.
You could use the other, but there are times when this method is much better, especially if you're winding up with a lot of fractions. If you're getting answers like x equals negative 13 over 49. Oh, wait, now I've got to substitute that in. Okay? This Kramer's rule, you know what? I'm going to move over here And write the problem down.
7x.
Oh, 7x
Plus 2y.
plus 2y
Equals 13.
equals 13.
And then 7x.
So 7x
Plus 3y.
plus 3y
Equals 12.
equals 12.
Very simple.
If it didn't say solve this using Kramer's rule, I think what I would think is, oh, it's tailor-made for elimination. Just multiply the bottom by -1. Wouldn't that eliminate the 7x's real nicely? But it says use Kramer's rule, so let me write down. Here's Kramer's rule. X equals dx over d. It's a subscript of x over d. And y is dy over d. Natural question to ask is, what the heck is d? What's dx and dy? Well, to find d, you're going to write what's called the coefficient matrix. We're going to be using this type of determinants. Okay, you're going to write 3 small determinants like this. Okay? I just showed y'all how to find determinants of the big matrices, but you're not using that for these. Just write down 7, 7, 2, 3. That D is called the determinant of the coefficient matrix.
You don't put the 13 in there?
No, just the coefficients. And do you remember how to do this one? Okay, so it's 21, then a minus 14. So D is 7. Now, so you start off by finding the determinant of the coefficient matrix. I tried to write out a sequence of steps for this in the video last semester, if I recall correctly, and my brother had never seen that done, and he was laughing at it. He'd never seen anything like it. It's just like trying to write out a sequence of steps of what I'm doing here. Oh, wow. In fact, I think in one class last semester, I might have even written out a formula using the first 9 letters of the alphabet, similar to AD minus BC. My brother just laughed and laughed. He couldn't believe I ever wrote that out in class. And I was like, oh, He was like, just show an example, don't write that out. I said, okay. So, for the subscripts, whatever the subscript is, you're going to replace that with these constants. And then do the crisscross. That's what this is called, crisscross. Replace the X column with 13 and 12. And then do that crisscross again. Whatever the subscript is, that's the column that you're replacing with these numbers over here. So it would be, when I do the crisscross, 39 minus 24. Is that what I heard?
So you take the 7-2 and 7-3, and then you basically shift it over, and you 2-3, or actually kind of backwards at 2-3. I guess.
Huh?
How are you? Okay, so you have the 7-7-2-3.
Okay, you write down the coefficients
Right.
and do the crisscross. That gets you D.
And then you put one coefficient.
Whatever the subscript is, you replace with these numbers over here. See, we haven't used the 13 and 12 yet.
Right.
You see, when you find D, you don't use the constants. It's just the coefficients.
So then where is the 2-3 coming from?
It's the Y. You're replacing the X with 13, 12, do the crisscross.
So what was the 7 for?
Which 7? Oh, this 7? I'm finding D. I found D.
Okay.
Now I've got to find dx and dy.
Is dy the same?
You find dy the same, but it probably won't be the same number. To find d subscript y, whatever the subscript is, that's the column you replace. You leave the x's 7 and 7. Replace the y's with 13 and 12.
So then it would be
Okay.
7 and 7.
7 and 7, 13, 12. Whatever the subscript is, you replace that column with these constants. And 7 times 12, that's 84 minus what? Let me see, what color am I using? Green? No. 7 times 13, 91. And what are we getting here? 84 minus 91, is that I'm thinking it's a negative 7. Right? Now, what have we done? Well, now you can plug into the formula. X equals dx over d. So x is 15 over 7. Y is what? I'm using dx over d.
Negative 7 over 7?
Negative 7 over 7. That we can reduce to what? It's to negative 1. So it's a nice way of, it's another way of finding or solving a system of equations. Years and years ago, I used to be smart. I remember in a programming class, the professor, who I really did not like, he didn't like us either, I know he didn't. Us being my brother and me, we were both in it. But he gave us the assignment, we had to write a program to solve systems of equations like this. And he assumed everyone was going to use elimination or substitution. He didn't say it must be elimination or substitution. And so I remember thinking, well, gosh, it would be so much easier just using this. You could easily write code for that. And
How would you write that? Would you just do the in parentheses,
Yeah.
15 over 7?
Mhm.
Okay. I just want to make sure.
but this little system, or this little method for solving a system of equations, is not as well known as elimination or substitution, but oh wow.
So
You could write a code, if you're a programmer, you could write code for it easily. So, parentheses, 15 over 7. See, this is what that student did that it counted wrong. Putting that comma down there. You're not supposed to put a comma in the bottom of a fraction or in a subscript. Negative 1. 15 over 7, comma, negative 1. Oh, it sure is slow now. And we're going to do one more like this. You see, look at this. Would it be easy to solve with elimination or substitution? Substitution would be horrible because you'd wind up having to divide. And so you're winding up plugging in a fraction. But this Kramer's rule, it doesn't matter what the numbers are. It's never really hard with Kramer's rule. They're all about the same. Let me write down the equations. 4x plus 5y equals 13. And 6x plus 2y equals 14. So find D, find dx, find dy. D,
She looked at me confused.
Oh
I said,
no,
"You'll
I
get
did it
You'll get
again.
it.
No,
Sorry, that was a doctor call.
yeah.
You'll get it. You'll get it.
Oh, this isn't hard. If I haven't broken your spirit yet, this is not the assignment that will
If you
break
haven't
your
broke my
spirit.
spirit.
I promise.
Years and years ago, a student told a class that they'd had Mr. Blah Blah and that it was so horrible that he broke their spirit.
I
It
had
wasn't
an
me.
algebra class that broke my spirit.
Oh, well.
Yeah, me too.
And we at that point we had there was one student in there really super smart. She laughed and laughed at that during class. You know, she couldn't believe it. And then the next semester she came back by and said, "I registered for him for blah blah blah, and let me tell you, now I feel sorry for her." No, she managed through it, but he broke her spirit. And, well, if I haven't broken your spirit yet, I'm not going to. Okay? This is not the course to do it, and I'm not the
So-
teacher.
The B is the first variable, so it's like 4 and 5 and 6 and 2.
Mm-hmm. Okay, so
Dx is going to be like basically plugging the x with the 13, right? So it'd be 4 and 13, right?
no, you replace the x
See, I'm
with.
still learning.
Okay, so you start off. D is the determinant of the coefficient matrix. Just write down these 4 digits here. I mean the 4 coefficients, and do the
Tie the shoelaces.
8 minus 30. So D is a negative 22. Then you find what's called D subscript X. Whatever the subscript is, that column gets replaced with these numbers here. So instead of the 4, 6, put 13, 14. Now the Y's stay at 5, 2.
That makes sense.
And do that little crisscross again. So it would be a 26 minus 70. And so that's a negative 44. Okay. So at this point right now you know the answer for x. Yeah, x is dx over d. dx divided by d would be what?
Oh,
A 2? Negative 44 over negative 22? But I'll write that out in a moment. One more. Find dy. Find dy. This time you leave the x's alone and replace the y's with 13, 14. And 56 minus 78. Now notice the way you always, when you're doing that crisscross, make sure you're starting with the first number. Okay? If you started up here with 30 first, you're going to get it wrong. See, 56 minus 78 is, it's going to be a negative, is it 22? So I think this one we're not going to have any fractions in our answer. That's now x is dx divided by d. So negative 44 over negative 22. So x would be a positive 2. And what about y? Y is dy over d. So negative 22 over negative 22, oh, that's going to work out nice. Just a positive 1.
It'll be 2, 1.
So 2, 1. Okay. Nice.
I get it.
I know, but like that.
I've got this too messy, and I'm going to transfer it over to the paper.
Did you get the picture on hers with the camera tool? So write that down somewhere. 'Cause that's
2,
where you get these.
1, close parentheses. Then there's some nice little applications of this stuff.
Y equals dy.
And that's what we'll do on 1 week from today. On Wednesday's Chromebook testing,
Which is here. See that?
or tablet testing if you have a tablet or something. And 1 week from today we'll finish this up.
Right.
And then we'll start working to review the final review. Okay? So this semester is almost over.
So now you have that.
If you have any questions, I'll try to answer them. Otherwise, I'll see you either on Wednesday to take the test or on Monday when we finish this up.